Suppose for example, there is a room. There is a room, and inside the room nobody is there. Inside the room nobody is there. And if somebody wants to go for sleep, then they can come and they can sleep freely. Now what happened here? Consumer is trying to go for sleeping. Consumer is trying to go for sleeping, but while going for the sleeping, somebody came and dragged him to other place. Don't sleep. This is consumer dragged from this place and say that don't sleep. Meanwhile, what is the meaning of this one? I made here preemption. That is what the code related to this one, right? While executing the line 1 and shifting to the line 2, somebody came and preempted me. So for that reason, what happened here? I am not going to sleep there. Now observe the situation. The producer will came to the blocked queue. I can say a blocked queue, or in our terminology you can say that it is room. Producer came here and check. Is there anyone inside the room? No. Nobody is there inside the room. So what the producer will think? Producer will think that yes, nobody is sleeping. I can happily produce the items. Right? So when count double equal to 1, wake up call is wasted. Fine. But as there is no person is there, I can say that I can produce as many items as possible for me. Right? I can happily produce the items. Now producer is producing the items. Producer is producing the items as like 1, 2, 3. Like I have taken the characters, right? Let us take X, Y, Z, K, L, M, N, O, and so on, right? While the producer is producing the items, at particular instance of time, the consumer came back, means this preemption is done. Means it came back and executing the line number 2 means what? It will go for sleeping state. Right? So and now consumer is in sleeping. But it doesn't known to the producer. And producer is producing the items and executing it. When it reaches to the full of the buffer, what it will do? When it reaches to the full of the buffer, producer is also went for sleep. Now producer will go for sleep. Producer also sleeping. Have you understood the scenario? Producer is sleeping. Now situation will be consumer is sleeping and producer is sleeping, right? So which means that both are sleeping forever. So why they are sleeping forever? Consumer is thinking that I will get the wake up call from the producer so that I can wake up and I can consume as many items as possible. And producer is thinking that while sleeping, I can get the wake up call from the consumer after consuming all the items from the buffer so that I can wake up and I can produce as many items as they want. Right? But the situation is here, both are sleeping because of initially whatever the wake up call we did is wasted, right? Which means both are going to be sleep forever. This will lead to a deadlock, right? Which means that I am the consumer and you are the producer. I am thinking that you will wake up me and you are thinking that I will wake up you, and both are sleeping. Both are sleeping. So when both are sleeping, nobody can be able to wake up. So that's this particular situation. We can call it as deadlock. So where the problem has risen, the problem has risen. It is because of the initial stage when the consumer is not there and wake up call got, and it is assuming that nobody is sleeping. Nobody is sleeping, and based on this assumption, it had got the problem. Now what will be the solution then? Just think about it, right? So the solution will be, when I came for wake upping some of the process in the blocked queue or in the room, I can put one tag. I can put at the entrance of the door, I can put one tag. I can say that don't sleep, and I am not going to wake up. I am not going to wake up. That's it. And it will came back and it will perform. It understood that nobody is sleeping and I can happily produce the items. Now when the consumer is coming back, it can check the door. Okay, it is writing that don't sleep, I am not going to wake up. Means that there is some person or some process already came to wake up me, but I am not there inside it. So by just looking at this one, they can understood that okay, fine, there is some work, so I should not go for sleep. Right? This is where we can solve the problem of deadlock. But in the real time, how we will implement this particular thing means, whenever you are sending a wake up signal, generally what you are doing, you are making one board kind of thing, right? In general, in the technically, when you are sending any kind of wake up signal, just maintain a bit, saying that don't sleep, something like that, right? The meaning is like, if I say 0 or if I say 1, which means that don't sleep. If I say 0, which means that sleep, something like that. You can maintain a bit, so that when a person came for sleeping, means whenever anyone goes for sleeping, by just looking at this particular bit, they can check whether they want to sleep or not will be decided, right? Yes, this is the way you can avoid the problem of deadlock. But the solution what we have discussed so far is related to one producer and one consumer. Fine, this solution will work fine. But the situation is, what about in the real world? We are going to have n producers and n consumers. Is this works fine? No, it won't work, right? Then what might be the solution? Just think it, right? So earlier we maintained one bit, means instead of maintaining a single bit, we might have an integer which can record total number of wake up calls have been made so far and how many number of consumers are not sleeping. Like that, if you are able to do, that might be the better solution. Means instead of maintaining a bit where I am not sleeping or don't go for sleep or go for sleep, like that, you can maintain an integer variable. Where this variable can record how many wake up calls made so far, something like that. How many wake up calls made, or how many consumers need not sleep, like that. How many consumers need not sleep. Then it can record, it can work for n producers and n consumers, right? So if I am going to maintain such kind of integer variable, it is called as semaphore. It is called as semaphore. Guys, what is semaphore then? Semaphore is a kind of a variable, which can contain an integer value. I can able to perform either read operation on that variable, or I can able to perform the write operation on that variable, or I can able to perform the update operation on that variable, right? Now, so this particular semaphore, what it will do is, it is going to record all kind of wake up calls in an integer, and which will keep on incrementing it, and whenever any consumer tries to go for sleep, and it will consume one wake up call, and it will decrement its operation, and do its task. See, when you are going to have certain positive value, see, observe, if it is semaphore is a kind of a variable v, if it contains 0, means there are no wake up calls, so that I can freely go for sleep. When it contains certain value 1, which means that what, I have so far got one wake up call. So if I am consuming something, I can decrement it and I can check it whether I can go for sleep or not, right? So as soon as it is decrementing, when somebody sees that integer value is going to be 0, which I can understood that there are no wake up calls, available. So now, can I go for sleep? Yes, I can happily go for sleep. Then when some wake up call got, again I will woke up, right? This is what happened, right? This entire concept what we discussed is called as semaphores, guys, right? Hope you understood. Now here the thing is, we are discussing semaphore, right? Semaphore is a kind of a variable. I said semaphore is a variable. Now as we are trying to work with variable means it is a kind of a data which is shared by all the n producers and n consumers. So now what will happen? If I am going to execute in user mode, this is a kind of data 0, 1, 2, 3, 4, or somebody will do 4 by 2, like that, right? All processes like n producers, consumers will try to work on this particular variable parallelly. Some producer 1, producer 2, producer 3, producer, and so on. All these people are trying to work parallelly. When all are working parallelly, there might be a preemption, and there might not be a preemption also, non-preemption also. At that situation, definitely this particular variable is going to provide again what problem? We have seen, when you are trying to share a common data among n processors, definitely you are going to face data inconsistency, right? Which means when you are going to use the variable in the user mode, you can face the data inconsistency problem. That's the reason this semaphores concept we are going to work in the kernel mode, right? So we'll see in depth about the semaphores in the next video. Hope you understood this video clearly. Thank you.